Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So let's move to the third type of the chemical bonding that we covered in our syllabus, which is the ionic bonding, or it is also known as the electrovalent bond. They are the same. Okay, so as what we have learned before about this type of the chemical bond, okay, it is actually rise due to the electrostatic attraction force between the cation and also the anion. Okay, so we have to fully remember, okay, that this ionic compound is actually formed due to this electrostatic attraction force, okay, between the two ions that is actually formed, okay, through the electron transferred. Okay, so how the electron being transferred? Okay, since that we know that this bond is the bond between the metal element and the non-metal element, so the metal element will donate its electron, okay, while the non-metal element receive the electron to achieve a stable configuration. So why the metal element is the one that donates the electron? Okay, this is because the metal are more electropositive and the non-metal receive the electron because it is the more electronegative atoms. So example of the formation of the ionic compound is in sodium chloride compound. Okay, so let's look at to the configuration of the sodium when it is in atomic form. Okay, the configuration is 1s2, 2s2, 2p6, 3s1. So when the sodium releases one of its electron that come from 3s orbitals, so sodium turns to Na+, and the Na+ configuration is lost with 2s2, 2p6, which is octets configuration. And then the chlorine that receive electron from sodium, it receive one electron. Initially, chlorine has the valence configuration of 3s2, 3p5. When it receives the electron, turns to chloride. So the one electron will come into 3p orbitals. So the chloride's configuration turns to 3s2, 3p6, and this is the octets configuration. So both of the Na+ and chloride achieve a stable configuration when the sodium release one electron and chlorine receive one electron. So after they form the Na+ and the chloride, okay, after these two ions form, and then they are being attracted, okay, by the electrostatic force, and they are forming ionic bond. So we have to be able to choose the formation of this ionic bond through the Lewis electron dot structure, okay, in which we have to draw the Lewis structure of both atoms. Okay, we know that sodium comes from group 1, so that it has one valence electron represented by 1 dot, and chlorine comes from group 17, so it has 7 valence electron represented by 7 dots. Then the electron transferred from Na to chlorine, okay, showing by this arrow, and it will form Na+ and chloride ion. So around the Na, no more dots, no more electron. As around the anion, we have to show that it has 8 dots around it, okay, and it achieve octet after receive the electron from Na, and it forms Cl-. Another example of the ionic compound that we can show is in the formation of the lithium fluoride. This is the initial configuration of lithium, lasts with 2s1, and the fluorine atom initially it lasts with 2s2, 2p5. So lithium release one electron that come from 2s and received by fluorine will enter to 2p orbital, so that the lithium plus configuration turns to 1s2, and fluoride configuration turns to 1s2, 2s2, 2p6. And shows the formation of this ionic bond through Lewis electron dot symbol. So lithium come from group 1, so 1 dot around it. Okay, the arrow towards fluorine. Fluorine has 7 dots around it initially, so that lithium turns to Li+, and then fluorine turns to F-. Okay, and this type is actually showing the formation of the anion and cation, and finally they will form ionic compound, which is Li+ and fluoride F-. Okay, so this is our compound. Okay, so let's try to show the formation of the ionic bond in other ionic compound. Magnesium oxide, we know that the magnesium oxide come from one Mg atom and one oxygen atom. Okay, so that it turns to MgO. So the Lewis structure of magnesium, we know that it comes from group 2, so it has 2 valence electron, 2 dots around it, react with oxygen group 16, so it has 6 valence electrons, so 6 dots around oxygen. And then the electron transferred from magnesium to oxygen, so the arrow from Mg to O, okay, and it will form Mg 2 plus ion, and oxygen 8 dots around it, O, since that it received 2 electrons, so it turns to O 2 minus. Another example of the ionic compound, if let's say we are having calcium chloride, CaCl2. So this CaCl2 is actually formed by the 1 calcium atom and 2 chlorine atom, so that the Lewis structure of calcium, okay, it has 2 valence electron, and then it is reacted with 2Cl that has 7 valence electron around it. Okay, the arrow to shows that the electron transferred from calcium to chlorine. Okay, and then it will form Ca2 plus and 2Cl, 8 dots around chlorine, minus. Another example, if we have aluminium oxide, Al2O3, it is come from 2 aluminium atoms and 3 oxygen atom. So it shows the formation of the ionic compound. So 2Al, Al group 13, so it has 3 valence electron that is reacted with 3 oxygen. So oxygen group 16, so it has 6 valence electron around it. Okay, then the electron transferred from aluminium to oxygen, so the arrow from Al to O, and then it will form 2Al 3 plus, since the Al released 3 electron, and 3 oxygen, each oxygen receive 2 electrons, so 3O 2 minus. Okay, so we have to show the electron for the anion, it is compulsory. Okay, no electron for the cation. This is how we show the formation of the ionic bond, okay, in the ionic compound. Okay, now let's look at to the properties of the ionic compound. Okay, they are solid at the room temperature. Okay, the ionic compound, they are solid at the room temperature. They have a high melting point and also high boiling point due to the strong electrostatic force between them, or the strong interparticle forces. Okay, the ionic compound also soluble in water. They can be dissolved in water to form a homogeneous solution. And in terms of the electrical conductivity, the ionic compound can conduct electricity in 2 states, okay, which are in liquid state or its molten state, and also aqueous state. Okay, this is because in these 2 states, okay, we have a mobile ion, okay, so the charge can be transferred. And the last properties, and this is the important properties of the ionic compound, okay, which is the ionic compound are brittle. Okay, so I want you to search in the textbook, okay, and you need to be able to explain the brittleness of the ionic compound. Okay, so see you. Assalamualaikum.